Subnetting a Class B network using FLSM, example number 2. This time, we've been allocated a Class B network address of 189.2.0.0, and we need to create at least 9 subnets with 64 addresses, and then 5 subnets with 100 addresses, and then 13 subnets with 70 addresses. Now, to clear this up, we're not looking to create 9 subnets with a total of 64 addresses, but 9 subnets with 64 addresses for each of those 9 subnets. So for example, for these 5 subnets with 100 addresses per subnet, it's going to be a total of 500 addresses for all of those 5 subnets. The way we do this is, first, we need to find a common subnet mask that satisfies all requested subnets, and then we need to count the number of subnets needed. So for our first task, we're going to look at the largest subnet, and that's obviously the 100 addresses subnet. If we satisfy the largest subnet, we're going to satisfy the smaller subnets. So we need to figure out how many bits we need to use for our host portion to be able to create at least 100 different addresses. That's going to be 7 bits because 2 to the power of 7 is 128. If we used 6 bits, that would be 64 different addresses. And that's actually enough for these 9 subnets, which require 64 addresses each, but it wouldn't be enough for the other 2 types of subnets. If we use the 7 bits for the host portion, we are left with 25 bits for the network portion. But we got a Class B network, which means that the first 16 bits are never going to change. So that's our default network portion. The bits that are left in between our network portion and our host portion is going to be our subnet portion. That brings us to our second task, which is count the number of subnets needed. So we need 9 subnets, and then 5 subnets, and then 13 subnets. In total, that's 27 subnets. Now we just need to make sure that we can fit the 27 subnets into our subnets portion. And this portion has 9 bits, which means that we could actually create 512 of these subnets. So our answer to this requirement is if we use 189.2.0.0/25, we could create all of these subnets. That's pretty simple, so let's look at an extra question. Let's name the first, the 11th, and the last subnet. The first one is obvious. It's going to be 189.2.0.0. 11th is a bit trickier. Let's go from the first. So this is the first, where we have all zeros in the subnets portion. And this is second, and then this is third. But we can't keep on going like this. What if you get asked, what's the 100th subnet out of 1,000? So we need to automate this. Let's look at it this way. If our third subnet has a value of 2, but we're looking at these 9 bits as if there is no dot. So if our third subnet has a value of 2, then our 11th subnet will have a value of 10. And this is going to be the value of 10 if we use 9 bits to write it in binary format. So this is our 11th subnet. If we wrote this in decimal format, this one has a value of 1 in this one octet. In this third octet, this is 1, and then this is 2 that switched off, and then this is 4. So our 11th subnet is going to be 189.2.5 in the third octet, and then 0 in our fourth octet. And this is, of course, /25. Finally, for our last subnet, so we said that in total we have 27 subnets. So we're looking at the 27 subnet here. So the 27 subnet is going to be 26 in binary format in our subnets portion. If we look at these 9 bits, this 0 is 1, and then this 1 is 2, and then this 0 is 4, and then this 1 is 8, and then this 1 is 16. When we all add all of those up, that's going to be 26. But then when we look at this octet, these are different values. So this is 1, and then this is 4, and then this is 8. In total, that's 13. So our 27th subnet is going to be 189.2.13.0. And of course, that's going to be with /25.